Hz SMCB, that is synchronous machine connected with circuit breaker system, delivers 1.0 per unit power. A fault occurs and the maximum power transfer capability changes as follows. Okay, pre-fault condition, post-fault condition, and during fault condition, maximum power transfer capability is given. Okay, we have to find here critical clearing angle. Okay, this is question based on equal area criteria. Okay, now there are three different conditions. We have pre-fault case. Let us take this one as pre-fault case, and this is during fault case, and this is a condition for post-fault case. How we can recognize this? Based on the maximum power. Pre-fault condition, it is 2.0, so this is pre-fault. What about during fault? During fault it is only 0.5 per unit, whereas okay, this is during fault condition, whereas post fault condition we have around 1.5 per unit. So we have a formula for finding delta CR, that is critical clearing angle. Cos delta CR is equal to PM times of delta max minus delta naught minus okay PM2 into cos delta naught plus PM3 into cos delta max divided by PM2 minus PM3 minus PM2. This is a formula for finding critical clearing angle, where delta naught is equal to okay, initially it is delivering 1.0 per unit. So what is delta naught? 1 sine inverse of PM by PM1. Okay, this is equal to delta naught. Now delta naught is equal to sine inverse of initial power is 1.0, whereas pre-fault condition we have maximum power of 2.0. So sine inverse of 1.2 is 30 degrees, or you can say this one as 0.523 radians. Similarly, we have to find delta max. Delta max is equal to pi minus sine inverse of PM by PM3. Okay, so this is pi minus sine inverse of what is PM3? Okay, this is PM1, whereas during fault is PM2, after fault is PM3. So this is sine inverse of PM by PM3, that is 1 by 1.5. You will get it as around 2.41 radians. Okay, now substitute all these values in the cos delta CR formula. Okay, now what is the final answer? You will get final answer critical clearing angle delta CR is equal to 70.3 degrees, which is option A.
Magnetic field intensity at 1.523 caused by a current filament of 24 amps in AZ direction extending from Z equals to 6 to infinite. Means suppose this is X, this is Y, this is Z. Current filament is located from Z equals to 6 to Z equals to infinite. So we have to find out magnetic field intensity at 1.523. So H is equals to 6 to infinite 6 of minus 2 AX cap plus 1.5 AY cap dz divided by pi of 1.5 square plus 3 minus z whole square 3 by 2. So if we solve this integral, we will get magnetic field intensity as 0.177 amps per meter. Hence option A is correct.
6 pole 6.6 kilovolts 400 kVA star connected synchronous motor has synchronous reactance of 15 ohms. Okay, XS is equal to 15 ohms per phase. Negligible armature resistance, so RA is given as 0 ohms. The motor is initially operating at 200 kilowatt at UPF. The field current is increased by 25% times the original one, and the load reduced by 40%. Okay, now earlier the motor is operating initially at 200 kilowatt at unity power factor. Now what happens if field current is increased? That means motor is overexcited. Okay, when motor is overexcited, what is the power factor? It leads to leading power factor. Okay, now since real power is constant here, active power is constant. Now what is Ia1 into cos theta 1, which is equal to Ia here. From this we can find what is the new leading power factor cos theta 1. This is Ia by Ia1, which is 100 by increased by 25%. So I can write this one as 125, which is equal to 0.8 leading. Okay, now earlier what is the armature current for 200 kilowatt? That is 200 into 10 power 3 root 3 into what is the terminal voltage, line to line voltage? He has given us 6.6 kilovolts. So this is 6660 volts into 1 because it is operating at unity power factor. Now armature current is 17.49 amperes, but field current is increased by 25%. So Ia1 is equal to 17.49 divided by 0.8, which is equal to 21.86 amperes. Okay, this is the field current we have. Now what is induced EMF EF? EF is given as square root of Vt into cos theta 1 plus Ia Ra whole square plus Vt into sin theta 1 plus Ia XS whole square. Okay, since this part is equal to 0, since we have negligible armature resistance, you will get this one as square root of 3048.4 whole square plus 2286.3 plus 327.9 whole square. Okay, this value is equal to 4015.8 volts. Okay, this is the induced EMF we have. Now keeping field current constant, the power is decreased. We know that what is per phase power? P by 3 is equal to EF into Vt by XS into sin delta 1. So what is this value here? EF is 4015.8 into Vt is 6.6 kilovolts divided by root 3. So this is 3018.5 divided by XS into sin delta 1 is equal to 120. That is, power is reduced by 40%. 200 into 40 is given as 120 kilowatt. So this is 120 kilowatt divided by 3. From this we can calculate sin delta 1 as 0.0392 radians. Okay, now what is Ia into XS? Ia into XS is given as EF square plus Vt square minus 2 times of EF into Vt into 0.99, that is power factor angle. Okay, Ia into XS, you can find this one as substituting these values. Okay, from this we know that XS is equal to 15 ohms per phase. From this we can find armature current as 49.16 amperes. Okay, now what is power factor? New power factor, this is a new armature current, so option B is correct in question 1. This is the correct option. Now what is the calculate the new power factor is the next question. Okay, we know that power factor is leading. Okay, the new power factor will be leading, so first option directly can eliminate. Now what about the remaining 3 options? We cannot, because remaining 3 options has mentioned leading. So we have to calculate the new leading power factor. Since load is reduced by 40%, so this is 120 into 10 power 3, that is 1,20,000 is the power, divided by 3 times of what is the terminal voltage we have? Terminal voltage is 3810.5. This is the phase voltage. Okay, so that's why we have mentioned here 3 times. Okay, 3 times of V phase, I phase. I phase is given as 41.16. This is the new armature current, which is equal to cos theta 2. That is a new power factor. You will get as 0.213 leading. That is option B is the correct answer.